Today we will move up to our next topic, which is the morphological. So this aspect we have completed. So whatever we are completing, this I have to put above it. No problem. We have completed this aspect. Structure, composition, and mechanism. And now we will move up to this morphology and tectonic domains of the oceanic floor. Okay, so I will write this thing here. Okay, morphology and tectonics that I will arrange. Don't worry about that. Morphology and tectonic domains of the oceanic floor. This is our topic for today. Okay. So you have studied this topic in tectonics also, in geomorphology also, and still we are going through this. Maybe we got a new perspective. We will see. So oceanic crustal types, first of all, you should study about this different oceanic crustal types. So in tectonics, there are different several crustal types. Around 13 types are there, in which 6 types are exclusively oceanic. Some are transitional. Transitional means they are hybrid type, means they are a combination of continent and ocean, and some are purely continent, and some are purely oceanic that are mentioned here, which are the oceanic ridges, oceanic basins, volcanic islands, trenches, island arcs, and back arc basins. So these are the things. And I know that I hope that you are familiar about, because they are very important. These are the locations where huge extensive volcanism took place and contributes for the development and formation of the oceanic crust. So so you see that image I have mentioned here, so I can just enlarge this thing. Okay. So this you see that on this side there are the on this side you have a continental side, similarly on this side also, and in between them you have the ocean. Okay, ocean. So up to this point, we would say up to this point, point. Similarly, up to this much point, we say okay that this is the continent part. Still, it lies beneath the ocean, but still it is the continental crust. And up to this point also, it lies beneath the continental crust, but still it is the sorry, what I'm saying. It lies beneath the ocean. Still, it is the continental crust. Okay, so the continental crust is extended somewhere more into the oceans. It is not just right away at this shoreline. It just extends itself around 300 400 kilometer beyond the shoreline into the oceans. Okay, so you see that. You see in this side also, on this side also. This side they have shown some mountain range that exist alongside the oceans, and on this side you have some beaches. Okay, in between them there are various submarine features in between that. Okay, that are usually present on the oceanic basins. These oceanic basins we have discussed about the different parts. So these are we know that the abyssal plain. What we call it, just remember this term, we call it the abyssal plain. Or also called oceanic basin. But this is the actual oceanic crust. This is the actual. ठीक है ना, ये आप याद रखेंगे. आपकी इसकी जो एवरेज डेप्थ रहती है, इट इज लाइक अराउंड मोर देन 4000 meters. More than 4000 meters that we have seen. Okay, so whatever you are able to see here lies over your abyssal plane. So you see some back arc spreading centers, some submarine volcanoes, some hydrothermal vents. This is a trench. Okay, sea mounts, some this iron and manganese nodules that are very much important currently. So deep water exploration is going on for the extraction of these Fe rich modules, and you have this chain of extensive volcanism, we all call it mid-oceanic ridges, and seamounts also on this side also. Okay, now, okay, so these are all the features. So you see that these are not small features, they are very very large features. Actually they are very enormous features, okay, compared to that of the mountain ranges that are present over the continents. You can just take these features of that order. Okay, so though they look very small, but they are very huge. Even the trenches are very very deep. Okay, this flexure, as you see, there's a flexure in the crust on this side as well as this side. So because of this, there's a huge depression that is created, a V-shaped depression like this. V-shaped depression is there. So in this V-shaped depression, a lot of sediments are being accumulated. So this is the most deepest part of the oceans. These trenches are the most deepest part of the oceans, and their average, I would say, is around 7,000 8,000 meters. The deepest we know is the Mariana Trench. The Challenger Deep is the deepest point in the Mariana Trench. Okay, so it is around 11 kilometers. So it is reported in the trenches only, and this Mariana Trench lies in the alongside the islands of the Mariana in Pacific Ocean. Okay, so I hope are you able to see now this properly? Hello.
Yes, sir. Yes, sir.
Okay.
Sir, where is the header zone?
This is known. This is the header zone only. This is the header zone. This is the header zone. Here you have trenches only. Okay, header zone is not this other part. This is the abyssal. This is the header. HDL header. Patal. Hades. Okay, it is came from some Greek gods, maybe Hades. Patal ke devta. Okay, this from there this name came from. Okay, so you see that this is the asthenosphere, which is the upper mantle, and extensive what do you say, magmatism is taking place, and it is rising, and
Lithosphere.
what?
Lithosphere.
Yeah, this is the lithospheric part. This brown colored part is the lithospheric part. Below this orangish reddish colored thing, you see it is the asthenosphere. It is mentioned there. Okay, so that's why it is shown like this. That this is undergoing under partial melting, and melts are being released, and they are rising because they are buoyant in nature, and they reach to the surface of the oceanic bottom and causes the formation of these black smokers, white smokers, along the spreading ridges and the back arc spreading ridges, or the mid-oceanic ridges, all this thing. Some hotspot related magmatism, maybe they shown. You can just take this as a hotspot related. This is something related to this dehydration, melting of this crustal slab that has subducted. Okay. So different types of melting are there. Okay, so now we are not going into that. Sorry, it is a part of English petrology. Okay, so this is the mid-oceanic, this oceanic ridges. First of all, I have told you that we should study these 6 oceanic crystal types, and we are going to each of them one by one. First is the oceanic ridges. Okay, how oceanic ridges are formed? What is the basis? What is the significance? We see. So you have learned about this Wilson cycle, and it is a part of the Wilson cycle. How continent, how a oceanic ridge is developed right away from the continent rifting. So you see that there is a, what to say, hotspot magmatism just right away from there. So this melts. What are these melts? They're trying to rise upwards, and because of this, there's a domal uplifting going on. This domal uplifting, what it does, it tries to break the crust apart. Okay, so what it does, okay, this part have gone here and this part have gone here, as you can see, and later on step like faults are being developed because of this extension that is being going on, and you see a lot of normal faults on this side, okay, and this is a rift valley like you see in Africa, that is currently developing in Africa. Some part of the Africa are in this stage where you see that there are a large number of volcanoes that are there, and this is also a situation. Some situations are also developing this way. So this is a rifting. Okay, so the crust is moving apart. You see a large amount of fissures and cracks that are present on the continental side, and they reported that maybe this particular part of the Africa will be detached from the mainland and will form a new continent of itself. So later on, with uh, more rifting and drifting, this particular thing will be opened up to this much level. So a linear sea would be developed. Linear sea means it is not that much extensive sea. It is like a huge canal, like similar to that of a Red Sea. Okay, similar to that of a Red Sea, as you can see on the map also. Where is Red Sea? So this you can just take. I'm just giving you some examples also. Okay, so this is African Rift Valley. This is the Red Sea, which is a linear sea. Okay, you can also note some examples also, because a lot of time these examples are being asked. ठीक है, ऐसे एग्जाम्पल दे देंगे, उठाएंगे अफ्रीकन रिफ्ट वैली और रेड सी और आपका मिड ओशियनिक रीजस। तो आप बताइए कि विल्सन साइकिल में आप अगर प्रोग्रेस करेंगे तो आप किस डायरेक्शन में जाएंगे। सो ये अरेंजमेंट करने को आपको मिल जाएगा। तो ऑब्वियस सी बात है, पहले रिफ्टिंग शुरू होगी, क्लीनर सी डेवलप होगा, एंड द सी विल बी with profuse extension. What is happening? This linear sea would develop up to this extensive ocean. ठीक है ना? This is a Atlantic Ocean. Let's take it the example of the Atlantic Ocean, and these are the mid-Atlantic ridges, and you see that these are the Americas on this side and the Europe and Africa on this side. This is the. Have you got this idea? Hello?
सर लिनियर सी का एग्जांपल है रेड सी।
Let's see.
ओके,
You can just check it on map. It is a very linear, very narrow strip. It is not that much extensive. ठीक है? Red Sea is a good example of. Okay, Red Sea के नीचे आपकी पूरी आपकी ये rifting हो रही है. So just read out the facts that oceanic ridges are linear rift systems in oceanic crust where new lithosphere is formed as a flanking. इधर उधर फ्लैंक करने वाले ये oceanic plate move away from each other. ये देख रहे हैं, ये फ्लैंकिंग, ये वाली, इसे फ्लैंकिंग बोलते हैं, इस ये वाला। दे आर टोपोग्राफिक हाइज, ऑब्वियसली दे आर टोपोग्राफिक हाइज। देखिए ये आपका क्या है, दिस इज द ओशनिक फ्लोर एंड दे आर एक्टिंग एज अ टोपोग्राफिक हाई। दे आर समवट हायर इन एलिवेशन कंपेयर टू दिस thing, compared to this ocean basins. The worldwide ocean bridge system is interconnected from ocean to ocean and is more than 70,000 किलोमीटर लॉन्ग। सो दिस इज, अब अगर आप कलेक्टिवली जितनी भी इंटरकनेक्टिंग रिजेस हैं उनके अगर लेंथ को अगर समाइशन करें तो अराउंड 70,000 किलोमीटर लॉन्ग होगी। जितनी भी कार्लसबर्ग हो गया, साउथ अटलांटिक हो गई, आपकी पैसिफिक में भी है, आपके अटलांटिक रिज है, बहुत सारे रिजेस हैं। ठीक है, द रिच क्रेस्ट आर कट बाय न्यूमरस transformed faults. So in this particular block diagram you couldn't be able to see it properly, but I will show you. But I have one. Very good. And
सर इट इज डाइवर्जेंट ना, हाउ इट इज अ ट्रांसफॉर्म फॉल्ट, इट इज डाइवर्जेंट ना।
yes, it is divergent in nature, but along with this divergent thing, मैं दिखाता आपको, आपने पूछ लिया तो मैं बता दे रहा हूँ। ओके, देयर इज अ डाइवर्जेंस गोइंग ऑन ना, ऐसे, ठीक है ना, बट आपकी ऐसे एक्सटेंस से कंटिन्यूटी नहीं होती, दे आर बीइंग ऑफसेट बाय सम ट्रांसफॉर्म फॉल्ट्स। ओके, लाइक दिस, हैव यू सीन?
यस सर, यस यस,
है ना? So this part, these are what? This part is the transform faults. ठीक है, this part is not transform fault, which I have extending by dotted line. Only that part, that is the shaded part, it is the transform faults. ठीक है, understood? So okay, so the ridge crest are cut. तो जो crest है आपकी कट होती है बार बार, एक तरह से ट्रंकेट होती है आपकी न्यूमरस ट्रांसफॉर्म फॉल्ट विच में ऑफसेट रिज। ऑफसेट का मतलब यही, सीधे जा रही थी और शिफ्ट कर दिया उसने उसको, रिच सेगमेंट्स, एक सेगमेंट ये, दूसरा सेगमेंट ये, बाय 1000 ऑफ किलोमीटर्स। ये अब इसमें ये जो डिस्टेंस हो सकता है ये 1000 ऑफ किलोमीटर्स का भी हो सकता है, जो मैंने छोटा सा दिखाया हुआ। फास्ट स्प्रेडिंग भी होती है रिजेस, स्लो स्प्रेडिंग भी होती है। तो फास्ट स्प्रेडिंग मींस 8 मिलीमीटर सॉरी 8 सेंटीमीटर पर ईयर। हाफ रेट मींस एक तरफ का, दूसरे तरफ का भी तो जोड़ोगे ना आप। एक तरफ का है मींस अगर आप इस पॉइंट से इस जगह पे जा रहे हैं, सिर्फ एक, इसको आप स्टेबल मान रहे हो, अभी कांस्टेंट है, ये मूव नहीं कर रहा, तो ये से ये तक कितना गया, 8 सेंटीमीटर पर ईयर में। तो ऑब्वियसली बात है, जितना इधर जाएगा उतना इधर भी जाएगा। तो फुल अगर देखेंगे, फुल रेट इज अराउंड 16 सेंटीमीटर पर ईयर, एंड स्लो इज अराउंड you will say 1.2 to 5 centimeter per year. They are characterized by the presence of normal faults. As you can see, these faults can also be seen on this continental crust site. You see that. Similarly here also. Examples: Carlsberg Ridge and Mid-Atlantic Ridge are the good examples. You see that. Okay? You see that. Very well shown. Understood? And this is the some cross-sectional diagram of the Mid-Atlantic Ridge. Understood this thing? I hope you got this thing. A block diagram, a very beautiful block diagram they have shown, where the mantle is upwelling. As you can see, this particular red thing, what is shown, this is showing that the melt is upwelling. Are you able to understand this thing? Anybody? Any problem?
No, sir. No, sir.
Great. I need this level of attentiveness from the students. Then only they can understand each and everything. Okay, the discussion is very important in online classes, which usually lacks. So what you see, this is also a thing that is observed around this mid-oceanic ridges. So this is this dotted line, as you can see. This is the crest of the ridge, and aside this crest of the ridge, and right side as well as on the left side, you can see some magnetic strips, some purple colored, some white colored magnetic strips, like a barcode. Okay, it seems like a barcode. So what is this? This represents different magnetic events. Okay, so this is a normal magnetic, and white color represent a reverse magnetic, and then normal, and this is alternate thing, normal reverse ऐसे ऐसे आपका आता जाता है, ठीक है। This particular thing is observed right away from the crest of the mid-oceanic ridge up to the continent size. अब जैसे जैसे कॉन्टिनेंट साइड की तरफ जाते जाओगे ना, आपको इस तरीके की स्ट्रिप्स आपको सिमेट्रिक नेचर में आपको देखने को मिल रही है। Okay, next is the oceanic basin, which is the most important thing. So a lot of geomorphologic features you'll be able to see over this oceanic basins. So
oceanic ridge is the continuous process, or बीच बीच में रह जाता है? ये continuous है कि कभी कभी होता है?
क्या किसकी बात कर रही हैं आप?
oceanic ridge
ridges की
ridge.
No, they are continuous, but sometimes they get truncated. Means आप जहां पर ये जाके truncate होगा, जहां पर ये जाके end होगा, terminate होगा, ठीक है ना, they get terminated by some other crustal type boundary. Maybe it can be a subduction zone, or it can be a some other type of ridge, है ना। तभी तो ये कंटिन्यूस, ऐसा नहीं कि कहीं ऐसे रैंडमली जाके टर्मिनेट हो गया, ओके, धीमे धीमे जाके डिमिनिश हो गई और खत्म हो गई, ऐसा नहीं होगा। जाएगी तो ओके, दिस इज जॉइंट समवेयर टू सम अदर रिच और सम अदर व्हाट यू कॉल इट, देयर इज अ डायग्राम yesterday. Yeah, you see that, okay, this particular thing is connected to some other ridges. Yeah, this is some other ridge, this is some other ridge, this, okay, this going, okay, this is connected to some other ridges. Okay, this is I'm showing you, and this you see, this is a subduction zone, and this has bended. There's some transform faults over this side, and again it has moved like this. So there's some other ridge, there's some other ridge. Okay, these ridges, this boundary of these ridges will define, as well as the ridges, as well as the transform, and the your subduction
Divergent.
zone boundary would define any plate boundary. Okay, so this is the CUCET plate, Nazca plate, all these plates, you see that.
Sir, what is the meaning of reverse magnetic polarity?
Okay,
What is the difference between reverse and normal?
this is the reverse. So what happens, though this is not a subject, but still I'm telling you this thing. It is a part of palemagnetism. Still I've mentioned, so I have to tell you about this. So this, as you know, Earth has have its own magnetic field. Okay, so the magnetic field are like this. You see that, like what we call it, well anal belts. We call it Van Allen belts. So this is like of this shape, इस तरीके की शेप के होते हैं, समझ रहे हो? So they move from north or they move from south. It can be reversed also, it can be like that also. So they move from north to south or from south to north. Means they are produced at there, so they are moving on diverging from this point and converging to the north pole side, the north pole. ठीक है ना? और कभी कभी ये उल्टा भी जाता है. तो आज के समय सिनारियो क्या है आपका? कुछ लोग ये भी कहते हैं, कुछ लोग ये भी कहते हैं कि दिस इज द नॉर्थ पोल करेक्टली एंड दिस इज द साउथ पोल, and things are moving from north to south, which is now obviously it is not the geographic poles, this is the magnetic poles. These magnetic field lines are diverging from the north magnetic pole every time, which is currently situated near the southern geographic pole. So आपके ऐसे निकल के जा रही हैं और कहाँ डाइवर्ज हो रही हैं जाके? It is diverging at the southern magnetic pole, which is situated at the where? Northern geographic pole, very near to this thing. Okay. So this events, okay, whether or this is on this side, whether on this side, will define you whether it will having a normal magnetic polarity or a reverse magnetic. Usually this particular polarity changes within some 100,000 years every time, and this type of things you can easily be retrieved from the raw data. You can easily be retrieved from the raw data. So currently what is the scenario? This is the scenario. Things are moving from here up to here. रिवर्स हो रहा है. जब रिवर्स हो रहा है तो रिवर्स नहीं बोलते हैं उसको, ये हम लोग मान के चलते हैं रिवर्स हो रहा है तो, बट दिस इज नॉर्मल फॉर अस बिकॉज व्हाट इज करंटली गोइंग इज नॉर्मल फॉर अस. दिस इज नॉर्मल. और अगर इसका उल्टा होगा देन इट इज रिवर्स. तो आज जो है, आज सिचुएशन क्या है उसको बोलते हैं नॉर्मल. आप देख सकते हैं तभी नॉर्मल जो है, दिस इज द रिसेंट है ना, रिसेंट आपका जो मैग्मा, जो आपका लावा इरप्ट हो रहा होगा, इट इज करंटली इरप्टिंग है ना, तभी यहाँ पर क्या है, you have the normal one. Then normal के आगे आपका फिर क्या आएगा, रिवर्स आएगा, फिर नॉर्मल आएगा, फिर you get reverse, फिर नॉर्मल, फिर रिवर्स, फिर नॉर्मल. So this particular thing I usually taught in paleo magnetism and magnetostratigraphy. That is a part of magnetostratigraphy. Okay, so it is a very detailed thing. You can't understand each thing here. It is a very detailed thing. The whole lecture would be given on this particular image. Okay, around the 30 slides lecture, 2-hour lecture. So now this is the oceanic basins. Okay, ocean basins are the most common and most widespread crystal type. Okay, so this usually covers around 30% other than more than any other crystal type. These basins make up around only 12% by volume. Okay, these are tectonically stable and characterized by thin sediment cover. Why thin sediment cover? Because these basins, so this, you see that this is the continent shelf side, this is a slope and you have a rise, and okay, we are now progressing into this, you say that okay, this is the part. I have made this boundary. This is the part of the abyssal plane which defines this abyssal plane. ठीक है ना? So now you see that this is very very far away from the oceans. Though it seems in the image it is very nearby, but I'm telling you it is thousands of kilometers away from this shore. Okay, so a very less amount of sediments would able to reach to this abyssal plane, and those sediments are also those suspended clay size particles that eventually fall and give rise to those shales. ठीक है ना? Shales that you find in the deep oceanic floor. So आपका क्या है? आपके अबाइसल प्लेन में आपके क्या है? आपके थिन सेडिमेंट टेक्टोनिकली स्टेबल होते हैं, क्योंकि जितना भी आपकी एक्टिविटीज होती है ज्यादातर वो आपकी इन पोर्शंस में नहीं होती हैं, आपके रिजेस के पास ज्यादा होती है, आपकी सबडक्शन जोन्स के पास होती है. ओके, लेकिन ये एरियाज बिल्कुल फ्री होते हैं, इससे कुछ ज्यादा कुछ नहीं होता. सो दी ओके, so and these particular anomalies that we have discussed earlier here can be seen all along this oceanic basins. आपकी अगर रिज है फॉर एग्जांपल, ठीक है ना, so you see that okay, normal polarity, we say reverse polarity, and normal polarity, reverse polarity, and normal polarity, then reverse polarity, for example. So you have a reverse which I am shading out. Okay, like this, like this. Okay. तो ये आपके जितने भी रिवर्सल्स हैं वो आपको ओशन बेसिन्स के ऊपर देखने को मिल जाएंगे. The sediment layer thickens near continents, arcs, near continents and arcs from which detrital sediments are supplied. ठीक है, तो जहां पर आपका सेडिमेंट सप्लाई होगी, जो भी सोर्स होंगे सेडिमेंट्स के, ऑब्वियसली बात है वो लोकेशंस प्रोमिनेंट होंगी जहां पर आपका थिक सेडिमेंट कवर रिपोर्ट किया जा रहा है. ठीक है, तो ये आपके कौन से हैं? दीज आर मेनली द योर नियर योर आइलैंड आर्क्स एज वेल एज योर कॉन्टिनेंट्स. And a common feature of this particular ocean basins are the abyssal. These are some not very large. These are some small features, some small mold-like features that are present. Okay, so these are known as abyssal hills. ज़्यादा बड़े नहीं होते. They are similarly like hills that we see. ठीक है, ज़्यादा mountains के size के नहीं, hills के size के 200-300 meter, not more than that. As you can see in this cross section. Okay, now next is the volcanic islands. Volcanic islands, very important. So these islands are formed because of some plume activity, because of some what activity? Plumage activity होती है, some hotspot activity. ठीक है ना? And very popular example of this volcanic islands we can give is the Hawaii Emperor Island chain, which is in पैसिफिक ओशन. कहां पर है आपकी? ये पैसिफिक ओशन में, आप याद रखेंगे. ठीक है ना? सो ये आपके volcanic islands where you are able to see that you can see those features in the oceanic basins only, over the oceanic basins only. ठीक है ना? तो ये सब चीजें आपको कहां देखने को मिलती है? ओशनिक basins. So there are large volcanoes that have erupted. Sorry, I will use this pointer. Okay, so there are large volcanoes that have erupted on the sea floor, whose tops have emerged above the sea level. If they are below sea level, they are called seamounts. तो जब ये आपके ओशन होता क्या है, देखिए मैं आपको बताता हूँ. ये स्टेनोस्फीयर है, and you have this hotspot. The hotspot activity goes on. This is a melted plume, as you can see. Rising magma is shown here, and because of this extensive volcanism, what is going? Crust is producing. Thus, the crust has produced up to that much extent. Then you can be able to see some volcanic rocks, the pileup of volcanic rocks that have piled to that much extent that it has gone and rose above the ocean. तो आपका क्या हो रहा है कि ये वॉल्केनिज्म हो रहा है। वॉल्केनिज्म होने के बाद क्या हो रहा है, इतना वॉल्केनिज्म हुआ, इतना वॉल्केनिज्म हुआ कि उसने पहली लेयर डेवलप की, दूसरी लेयर डेवलप की, तीसरी लेयर डेवलप की, इतनी लेयर डेवलप की कि ओशन की जो डेप्थ होती है, अब ओशन बेसिस में है आपकी, यूजुअली यू फाउंड इन द ओशन बेसिस विच इज यूजुअली लाइक अराउंड 4500 4800 मीटर्स इन डेप्थ। और आपको उस पर्टिकुलर हाइट को अटेन किया, मतलब अराउंड 4500 मीटर की हाइट को अटेन किया हमने, क्योंकि ये चीज ओशन फ्लोर के जो बेस है इनका, वो ओशन फ्लोर है, उससे डेवलप होना शुरू हुए और इतना ज्यादा एक्सटेंसिव वॉल्केनिज्म हुआ, इतना ज्यादा होता है इनमें, क्योंकि देयर सप्लाई इज अनलिमिटेड, दे आर नॉट प्रोड्यूस बिकॉज ऑफ सम डिहाइड्रेशन मेल्टिंग और सम अदर काइंड ऑफ मेल्टिंग। ये तो सीधे सीधे आपकी मेंटल से डायरेक्ट सप्लाई आती है, ठीक है ना, बहुत ज्यादा एक्सपेंसिव होता है इसमें। तो होते 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 इतना हो गया कि it now rose above the oceanic surface, and now it is you can say subaerial in nature. This part is submarine, the flanks are submarine, and the central part you see that is mainly subaerial, ठीक है ना, because it is rising above the this ocean. Okay, so Hawaii is a very good example. As you can see in this image, there are some different islands that are shown. These are what? These are those volcanic islands only. So they are composed totally of those volcanic islands. ठीक है ना? They are composed totally of this volcanic islands. So what happens with time? आपकी क्या होती है? प्लेट मूव करती है, ठीक है ना। आपकी क्या होती है, आपका क्या होता है, योर प्लेट स्टार्ट्स टू, ठीक है ना। सो आई थिंक दे हैव इनकरेक्टली mentioned this thing, it should be on this side, the plate movement should be on this side, इस तरह मूव कर रही है। तो यहाँ पर क्या हुआ, हॉटस्पॉट ने एक्टिविटी की, आपको बनाया, फिर ये आपका क्या चला जाएगा, इट इज लाइक अ कन्वेयर बेल्ट, इट इज लाइक अ कन्वेयर बेल्ट। इसको कुछ ये आपका क्या बना, ये आपका वॉल्केनिक आइलैंड बना, नाउ इट विल गो ऑन दिस साइड, ठीक है ना। सो क्या होगा जब दिस साइड क्या होगा, अब इसके बाद क्या होगा कि आपका जो वॉल्केनो जो नीचे की सप्लाई थी वो तो अब स्टॉप हो गई, बिकॉज हॉटस्पॉट्स जो होते हैं दे आर फिक्स एट अ लोकेशन ऑन द कस्ट, ये मूव नहीं करते, ये प्लेट के साथ मूव नहीं करते, देयर लोकेशन इज फिक्स्ड, ठीक है। तो ये क्या हो गए, ये आपके इधर से, ये आपका जो वॉल्केनिक आइलैंड था ये क्या हुआ, इधर मूव कर गया आपका, फिर नया वॉल्केनिक आइलैंड फॉर्म होगा, ठीक है ना, फिर नया वॉल्केनिक आपका आइलैंड क्या होगा, फॉर्म होगा दूसरी जगह पे, धीमे धीमे करके। कितना बड़ा वॉल्केनिक आइलैंड फॉर्म होगा डिपेंड ये करता है कि आपका प्लेट का मूवमेंट क्या है। अगर आपका प्लेट का मूवमेंट इतना ज्यादा नहीं है तो देन इसको टाइम मिलेगा, अच्छा खासा आइलैंड आपका फॉर्म होगा। अगर जल्दी जल्दी मूवमेंट हो रहा है तो उसको समय नहीं मिलेगा और वो कभी भी ओशन सरफेस के ऊपर नहीं आ पाएगा, ठीक है ना। तो ये चीज आपको समझना बहुत जरूरी है। तो ना ये आपकी प्रीवियस डेवलप्ड क्या है, ये आपके ये प्रीवियस डेवलप्ड प्रीवियसली फॉर्म्ड volcanic islands, ठीक है, previously formed volcanic islands that have that have eroded, that have weathered, eroded, and what is happening now, they have attained a height up to this much point. Now because of this erosion they have attained this height, and a time will come it will go below the oceanic surface, and you can see some corals are developing on the flanks of this oceanic sorry this submerged volcanic island, and eventually what happens, the central part will get eroded, while these corals that are been developed on the flanks of this volcanic island will grow bigger and bigger, ठीक है ना, and their colonies will grow, and finally you have a seamountain, ठीक है, तो ये दिस इज द डिफरेंस, दिस इज द वॉल्केनिक, एंड ओवर द सरफेस दे वुड लुक लाइक दिस, ओवर द सरफेस दिस थिंग वुड लुक लाइक this thing would look like this thing would look like this thing is this, and this thing is this. Okay, so what is there? This is a volcanic island. Okay, volcanism going on. अब क्या हो गया आपका, क्योंकि ये चीज अब इसमें इवॉल्व कर जाएगी, तो एवोल्यूशन का जो साइड है, दिस इज द एवोल्यूशन विद टाइम. ठीक है, ये आपका सिंकिंग आइलैंड है, सिंक कर रहा है बिकॉज ऑफ इरोजन, ठीक है, बिकॉज ऑफ वेव एक्शन. ठीक है, क्योंकि अब क्या है, नीचे से सप्लाई है नहीं, लेकिन स्टिल इरोजन तो एक्टिव है. पहले क्या था, इरोजन इसमें भी हो रहा था, बट स्टिल नीचे से सप्लाई थी ना, तो जितना मटेरियल ऐड हो रहा था उससे कमी मटेरियल जो है आपका. एंड देन यू हैव दिस गुयोट्स. Gourds are, you can say, a tabletop like use. It is like a mesa, a submarine mesa. Submarine mesa. Mesa is a landform that we study. The tabletop hills. And gourds. And you have barrier reefs. Barrier reefs में आप देख सकते हैं, there's a reef colony, this coral reef colonies that are developed like this. And in middle of this you have a small sinking island. And when the sinking island is gone and you only have a ring of this, what do you call it, coral reefs, we call it atoll. It is like a ring like island. ठीक है ना, this is the ring like island. And finally you have a seamount. Seamount means कि बहुत ज़्यादा extensive erosion हो चुका है और बहुत हद नीचे तक ये चला गया. So ये आपकी पूरी आपकी चेन है. So the plate movement is like this, इस तरफ मूव कर रही है प्लेट. ठीक है, प्लेट मूवमेंट क्या हुआ, इस तरफ का है. तो आपका क्या है, ये अगर एज वाइज अरेंज करना होगा, ऑब्वियस सी बात है, ये ओल्डेस्ट होगा, ये ओल्डर होंगे, ये यंगर होगा और ये आपका यंगेस्ट होंगे. ठीक है, बिकॉज हवाई विच इज वेरी फेमस, विच इज अ it is within the United States actually, though it is not in the mainland, but it is a territory of United States. Okay, very big island. So आप भी देख सकते हैं, ये कुछ दिखाया गया है यहाँ पर. This is a very famous two very famous volcanoes like Kialulia and Mauna Loa, okay, which are situated on this island. And ये island क्या है, ये island बस और बस आपका extensive volcanism की वजह से बना है. ये समझ सकते हैं, ये किसकी वजह से बना, एक्सटेंसिव वॉल्केनिज्म की वजह से आपका ये आइलैंड. सो दे अकर इन द ओशनिक बेसिन्स. दे आर large volcanoes that erupted on the oceanic floor whose tops have emerged above the sea level. ठीक है ना, if they are below the sea level they are called seamounts. Volcanic island and seamounts range in tectonic stability for intermediate or unstable in areas where volcanism is active, like Hawaii and Reunion. Reunion is also there in the African plate, actually, very near to this Madagascar. To stable in areas where areas of extensive volcanism like this. This is extent volcanism, but here it is active. But still you are able to see some of these islands. ठीक है ना, इसके और आगे तक जाती है, बहुत छोटा सा पार्ट दिखाया है हवाई आइलैंड्स का, ये चेन बहुत आगे तक जाती है. मैं आपको बताऊं, ये बस ग्रुप ऑफ आइलैंड्स थोड़े से छोटे से दिखाए हैं, ये चेन बहुत आगे तक जाती है, बहुत बड़ी चेन है, आप देख सकते हैं मैप पे भी. So gourds are flat topped seamounts produced by erosion at sea level followed by submersion. And coral reefs grow on some gourds as they sink, producing atolls. ठीक है ना, atolls याद रखिएगा, वो चीजें हैं, डिफरेंस याद रखिएगा. Then you have the trenches, very important. ठीक है ना, which is the deepest parts. Trenches क्या हमारे deepest parts हैं. So oceanic trenches mark the beginning of subduction zones and are associated with intense earthquake activity. क्या होती है, एक्टिविटी कैसी होती है, बहुत ज्यादा इंटेंस होती है भाई. Okay, because here the subduction is taking place. So you see that. So you have this uh, ocean continent, अच्छा लिख रखा है वैसे, and you have this ocean. Okay, you have an ocean continent and you have a ocean. So this is the continent plate which I have marked, and this is the ocean plate. So ocean plate, every times the ocean plate gets subducted because of its high density, it gets subducted beneath the continental crust. Okay, this is the, and because of this partial melting, you can see the development of some magmatic arcs and continental arcs over the continent side. And similar type of things you are also see when there is a ocean collision, and despite of despite the formation of the continental arc or magmatic arc, there is a formation of island arcs. It's island, the chain of islands have been shown, and if you see on a map, they would look like an arc like this. There is the island arc. If you track those volcanoes on a global level scale, they give an impression like they are distributed along an arc. That's why the name came from island arcs. So this trenches usually run along this continental arcs, and this island arcs usually run parallel to these trenches. Okay, na? As you can see, the depth range is around 5 to 8 kilometers, representing the deepest part of the oceans. They contain relatively small amount of sediments. Why small? Not, we can't say this thing because this statement is not true in every sense. Because those trenches sometimes are very far away in the case of continent, and if they are very nearby, like in the case of this continent and oceanic, so you see that a lot of supply of sediments is there, and this will fall down and fill these basins, these trenches. Okay. So this is the thing. There resemble a narrow trough. Trough का मतलब depression. A landward side of the trench rises as a volcanic arc that may produce islands such as islands of Japan, island arcs. Okay. The deepest point on our surface is around this 11 kilometer. Is found in the Challenger Deep area of the Mariana Trench. The majority of oceanic trenches are found along the margins of the Pacific Ocean. You see that. Now we move to the island arc, which is the next crystal type. Do you have any questions on these 3 slides? Sorry, I forgot to ask whether you have any questions or not. You are getting bored. Hello?
So, what is the difference between the volcanic arc and the island arc or the continental arc? These are also a volcanic
See,
activity. What's going on?
both of them are volcanoes only. Okay, na? One is developed over a continent plate in the continent arc, and one is developed over an oceanic plate. In terms of what you call it rock types that these different type of volcanoes produce are very different. So ऐसे आप if you ask from here, then it is not much difference. But if you ask from geochemistry point of view, if you ask this question from igneous point of view, then there's strong difference between them. The rocks, for example, you produce some andesitic type of magma. You can lava, both of the settings. Those andesitic type, I hope, are you from geology background? Hello?
Yes, sir. Yes,
Okay,
I'm
then you
from
might be
the.
familiar of this andesitic thing, I hope so. So this andesitic type, whenever it is produces from continental or whenever it is produces from an island, you can make the difference whether it is produced from continent or an island by looking at their geochemistry. By looking at their geochemistry. So there's a strong difference between them, but the difference is doesn't lies in this oceanography subject. It usually lies in geochemistry and spectrology. Only you can just understand that, and also economic geology also. Economic geology also, different types of deposits. Some types are associated with the continental arc, and some types are associated with the island arcs. Okay, like the volcanogenic massive sulfides, they're associated with the island arcs, while the porphyry copper deposits are associated with the continental arcs. Well, this is, I'm just giving you some more options. You can have an idea, but you can just know both are volcanoes only. Take it. One is present over a continental plate, okay, continental crust, and one is developed over a oceanic crust. And the development, how they are developed, and how they get evolved. ठीक है ना? Evolution is slightly different in both of the cases, but the how they get developed, what is the mechanism, what kind of melting have took place for the development are same, which is dehydration, or sorry, flux induced melting we call it. That is the prominent mechanism. Have you got this?
Yes, sir. Yes, sir.
So this is example, you can take that Japan. For the continental arc, you can take at the Andes mountain range. Examples are very important every time. Okay, next is the island arcs. Island arcs, as you can see, that I have mentioned here also, these island arcs. So because we are dealing with the continental oceanic crustal types only, whenever I teach tectonics, maybe some other person would teach, then he should also cover this continental arc ones. But we are studying oceanography only, so we are only focusing on this island arc. We're not focusing on the continental arc. So island arcs, as you see this particular diagram, just see, have a look. Okay, this particular diagram map will show you what is the distribution of various island arcs, and you see that these island arcs are situated just aside to this subduction boundaries. You see that okay, they are very
Sir?
widespread, huh?
Sir, like, is it due to ocean subduction?
In the case of this, here you asking it now?
For island arc, yes.
Yes, obviously, island arcs, it means this ocean subduction. If there's an ocean continent subduction, then they are continental arcs. No? Or you can
Oops.
develop an island arc when there's a ocean continent subduction. Okay, have you got this thing?
Yes, yes.
Okay, so this is though just okay. You have a confusion that all of them are islands. No, this is the continent. I can understand what is the problem. This Guatemala that is over the Central America, then this is the continent, or you also call it magmatic also. This is also continent. But what you see here, Tonga and New Zealand and Papua New Guinea, Mariana, okay. Then you have this Japan, okay. All you can see, these Aleutian Islands are also there. This is the Aleutian Islands. This is the Japan. This one. Okay, now. So Camargue arc, different names are being given. Some names are on the basis of the islands and some countries that are situated here. Okay, you have the Indonesian arc. How you can forget the Indonesian arc? This is Indonesian arc. Some Papua New Guinea is there. No, this is Papua New Guinea. Understood this thing? So these are the, so on this side, if you consider this is the Pacific Ring of Fire, we actually call it. This is a whole ring like this, going like this.
The trench are also present there.
Yes.
It is parallel to the
yes, it is
island.
dotted lines. The dotted lines represent the trenches only. Okay, the dotted lines represents the trenches only. Okay, so let me show you this thing. In Google Earth, you can able to see each and everything, very clearly, because the resolution is so much good. It also shows you some underwater features. Okay, हाँ भाई load कर लो. Okay, so you see that we are focusing on this part. Now it is very huge. Now see, you can see how much huge is specific. How much huge is specific. We couldn't be able to see this end, and we couldn't be able to see this end. We have to go like this. Okay, just we should focus on some this. You see that this is this particular dark color. Do you see? आपको दिख रहा है ये?
Yes, sir.
ये this curvature, this semicircle curvature. This is a trace of the plates, plate contact. This is a plate contact. So this is the trenches where the subduction is going on. This dark colored. ठीक है? This dark colored. And what you see? ये dot 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 दिख रहे हैं छोटे छोटे. These dots you see. Small dots. I hope I should do more.
Sir, yes, sir. Yes.
Yeah, ये देखे छोटे छोटे. ये दिखा, ये दिखा, ये दिखा, ये दिखा, ये दिखा, ये दिखा. What are they? These are they are not that much far away. तो आप समझिए प्लेट जा रही होगी, इसके नीचे जा रही होगी. इस वाले पार्ट की प्लेट जो है नीचे, the plate is going like this, and the melting of this plate have developed this, and cause the generation of the formation. Sorry, generation of this island arc over here. Okay, over the overriding plate. So this is the subducting plate. This is the overriding plate. As you can see, this particular part is more of a higher in elevation, and it seems like it is higher in elevation. And as you can see that, just see, this is the palm. ये मेरा जो कर्सर है, palm की तरह शो हो रहा है आपका. तो आप देखिए ये जो साइड में ना, इधर देखिएगा साइड में, ये देख रहे हैं मेरे, ये टाइम लिख के आ रहा है ना, नीचे की तरफ 3 मार्च. तो 3 मार्च के ऊपर आप देखिए एलिवेशन लिख के आ रहा है. आपने देखा एलिवेशन लिख के आ रहा है, ELEV करके. You have some data, some coordinates, then you have this elevation. I hope you can able to see this elevation on this bottom part, right bottom part, where Google Earth is mentioned. So see that. Okay, see, अब मैं ऐसे palm अपना move कर रहा हूँ from left to right. So आप देखिएगा कैसे धीमे धीमे मूव कर रहा हूँ. Just focus. You should focus. You should not focus on the palm. You should focus on the elevation part. Okay, now we are at the trench. Just see, we have achieved a negative elevation of around 5800 or 5900 meters. That is more than that of the average ocean basin. Okay, and then okay, 6000, 7000. Oh my goodness. So 6000, 7000 somewhere here. And then we move up to this part. Okay, we move away. Then we got around there. ठीक है, समझ में आया चीज? तुम जैसे these are, हाँ?
Yes, sir.
Okay, so now you got this. So you got this chain, the whole chain of this island arcs. That's why they are known as arc, because अगर आप दूर से देखो इस elevation से, तो ये arc की तरह की चेन दिखती है. arc ऐसा दिखता है, ये ऐसे जा रहा है, like a shape of a banana. Okay, so similarly you see this Japan island itself is an island arc. अब आप समझिए कि अब ये छोटे छोटे से हैं, अभी इनमें कितना एक्सटेंसिव वॉल्केनिज्म हुआ है, कि इतना हुआ है कि इसने पूरा एक आइलैंड डेवलप कर दिया बड़ा सा, और इसके बगल वाले ने आइलैंड डेवलप कर लिया. इतना डेवलप कर लिया कि इसके द्वारा जो डेवलप किया आइलैंड है और इसके द्वारा जो डेवलप किया आइलैंड है वो अब ज्वाइन हो गए, इसका ज्वाइन हो गया, इसका ज्वाइन हो गया, इसका, उसने एक पूरा कंटिन्यूअस बड़ा सा एक आइलैंड बना दिया, ओवर विच द पीपल आर स्टेइंग. दिस इज द जापान. दैट वाई वहां पर वॉल्केनो आपके, अब देखिए आप वॉल्केनो, अब आप बोलते हैं कि हाँ भाई वो क्यों, आप देख सकते हैं, आप दूर से देखिए कितना नियर बाय द कंट्री. दिस वेस्टर्न कोस्ट ऑफ दिस कंट्री जापान इज वेरी वेरी नियर बाय टू दिस सबडक्शन जोन, ह्यूज सबडक्शन जोन मैन. वो डिप्रेशन देखने में लग रहा है. अब देखिए कितना नीचे है. दिस इज द ट्रेंच, around 7000 meters, minus 7000 meters, and then we move up to this side. ठीक है। सो यहाँ पर आपका क्या होता है, मूवमेंट होता है जिसकी वजह से सुनामी आती है। उस सुनामी को ज्यादा टाइम नहीं लगता यहाँ से यहाँ पहुंचने में, ज्यादा टाइम, इट इज वेरी वेरी नियर बाय यार, ठीक है ना। इट इज लाइक अराउंड मैक्स टू मैक्स 700 किलोमीटर, 700 किलोमीटर कुछ नहीं होता सुनामी के। देख सुनामी की यूजुअल जो स्पीड होती है वो 300-400 किलोमीटर होती है, किसी को हुआ भी 2 घंटे में कोई कुछ नहीं पढ़ पाएगा, ठीक है। वो इतनी तेज मूव करती है, 500 किलोमीटर, बियॉन्ड 500 किलोमीटर तक की स्पीड रिकॉर्ड की गई है सुनामी की, ठीक है। उनके पास इतना टाइम नहीं रिस्पॉन्ड करने का। अर्थक्वेक आया, जैसे ही अर्थक्वेक आता जापान के लोग समझ जाते हैं अब प्रॉब्लम आने वाली है, बिकॉज अर्थक्वेक इस बेल्ट में आया होगा, यहाँ कहीं नहीं आता, आइलैंड पे कभी नहीं आते, आइलैंड पे कभी नहीं आता। इस आइलैंड पे क्या कहाँ आएगा आप बताइए। एपिसेंटर्स जो जाएंगे वो यहाँ कहीं जाएंगे, इन जगहों पे जाएंगे। जैसे ही उन्होंने देखा वो अर्थक्वेक आया, लोगों को प्रॉब्लम फील होनी शुरू हो गई, अब लोग कह रहे हैं अब तो सुनामी आने वाली है, ठीक है। तो नाउ यू गॉट एन आइडिया। सिमिलरली दिस इज द होल, नाउ यू सी यहाँ पर थोड़े थोड़े डेवलप हुए हैं, देख सकते हैं आप,
Yes.
है ना। ये ऐसे जा रहे हैं, ये कनेक्ट, ऐसा लग रहा है कि कनेक्ट होने वाले थे लेकिन प्रॉपरली हो नहीं पाया है सही से। लाइक जस्ट वी आर, आई एम शोइंग ऑफ दिस कोरल आइलैंड्स, so you see that a volcano is there, beautiful volcano is there. So I'm showing you
But
three.
the name of the volcano is the name of the volcano.
This Vulcan Cravo. You don't have to remember this. There are thousand, man, thousand of volcanoes. Just move a little bit, you find one volcano, one more volcano. और मिल गया,
Okay.
है ना। फिर आप मूव करोगे ना, इसी लाइन पे मूव करते हैं, चलो फिर मिल गया एक छोटा सा। अब देखो ये इतना अभी यहाँ पर हुआ नहीं है इतना वोल्केनिज्म, जिसकी वजह से पानी के ऊपर थोड़ा सा ही आया है, ठीक है ना। क्रेटर ही विजिबल है, फ्लैंक्स विजिबल नहीं है उसके, यू सी। अब आप ऐसे मूव करते जाओगे ना तो आपको दिखता जाएगा, देखिए आप। नाउ यू गॉट एन आइडिया ना।
Yes, sir. Yes.
Okay, so these are the things, we are somewhere here, I'm showing you thing, okay। And your next thing, I hope you can understand each and everything what is mentioned here, nothing much technical। And next is the Becker basins. So Becker basins are developed when it is developed, ठीक है ना, when there is a steep subduction। So this steep subduction creates a void, a space here, and this space is created because of this uh, you can say a strong convection current is developed, strong convection currents are developed। so आपके convections होते हैं, ये mental पहले यहाँ पे convection में लगते हैं, क्योंकि यहाँ पर आपका क्या था, स्लैब ऐसे हो, तो ये रीजन क्या है इसका, ट्रेंच रोल बैक इज द रीजन, ट्रेंच रोल बैक, ठीक है। ये टर्म्स मैं ज्यादा टेक्निकल टर्म्स में नहीं जाऊंगा बिकॉज़ यू आर समथिंग रिलेटेड टू टेक्टोनिक्स। तो ये दिस द
So what is the term?
ट्रेंच रोल
Trench?
बैक, ट्रेंच रोल बैक। You just read about this, what is trench rollback, so you must be familiar with the new term which is something related to tectonics only, ठीक है। तो आपका जो सबडक्शन एंगल होता है that differs, तो बैक आर्क हमेशा जरूरी नहीं कि हमेशा बने, लेकिन जहां पर आपका स्टीप सबडक्शंस होता है वहां पर आपके बैक आर्क बेसिन्स बनते हैं, ठीक है ना। एंड दिस आर यू कैन से माइनर टाइप ऑफ मिड ओशनिक रिजेस, छोटी टाइप की मिड ओशनिक रिजेस होती हैं, ज्यादा बड़ी नहीं होती हैं, लेकिन स्टिल दे आर एक्सटेंशनल इन नेचर, ठीक है, दे आर एक्सटेंशनल इन नेचर। एंड इन दिस इमेज यू कैन सी, सॉरी, this particular basin you see, because this is the subduction, you have a island arc, and behind this island arc there is a basin, this, और obviously आपका ओशन ही है उसके ऊपर, तो ये आपके बेसिन हैं, ये आपके क्या है, ये आपके बैकार बेसिन हैं, ये आपका साउथ, ये सी ऑफ जापान, कोरल बेसिन, ये सब क्या है, ये कोरल बेसिन, सी ऑफ जापान, दीज आर बांदा बेसिन, है ना। तो ये आपके क्या है, ये आपके बैकार बेसिन हैं। सिमिलरली यू सी दैट नॉर्थ फिजी बेसिन, लाओ बेसिन, हार्वे ट्रफ, ऑल आर दोस बैकार बेसिन्स। ओकिनावा, वेरी फेमस ओकिनावा ट्रफ, ठीक है। तो ये आप ध्यान रखिएगा, कुछ नाम आप भी ध्यान रखिएगा क्योंकि कभी कभी हो सकता है नाम पे पूछ लें, तो कुछ इंपॉर्टेंट नाम यही है। जब भी जो एग्जाम्पल्स आते हैं वो वर्ल्ड से नहीं आते, वर्ल्ड में रैंडमली कहीं से नहीं आते, मेनली जो फेमस वाले हैं वो अराउंड दिस पैसिफिक ग्रिडल ऑफ फायर में ही मिलते हैं, ठीक है। सो दिस आर द 6 crustal types, okay, that we have discussed. Tomorrow some more thing I will discuss about some part which is other features, but these are the major ones. Okay, these are the six different tectonic domains or crustal types. Okay, so again you can read about this more. I haven't gone much deep, थोड़ा थोड़ा ही मैंने बताया है, because it is not a tectonic. अगर होता तो मैं बेकार बेसिस का एक्चुअल फॉर्मेशन बताता, बट अल्टीमेटली फिर टेक्टोनिक्स में क्या पढ़ाएंगे, ठीक है। I hope you got this idea. So tomorrow we will complete this part, this aspect, very rapidly. Not much technical things are there, very familiar things, and even you can read yourself also. But some people ask me about this transform fault, so यही वाला किसी ने पूछा था तो मैं बताने वाला था. Still we will take this thing tomorrow, and after that hypsometry of ocean floor and continents.